Okay, welcome to the next part. So here we will see second type question on the same topic. The question says here, find the value of m for which the following system of linear equations will be inconsistent. 3x plus 1 equal to 1, 3x plus y equal to 1 first equation, 2m minus 1x plus m minus 1y is equal to m plus 1 second equation. So these are the two equations. If you see here the difference between the first and first question and this one, so here the condition given is inconsistent. So in number one it was given directly, see it says unique solution, so we used unique solution condition. Now in this case, instead of asking unique solution, no solution, or infinite many solution, they used the term inconsistent. So inconsistent, again we know this inconsistent is nothing but no solution case, no solution condition, that is when lines are parallel. So in examination they may ask you in this way also. That's why those synonyms or whatever we learned for these three conditions with different names are important. So you must remember those terms. So inconsistent, we know this is not difficult, which is no solution. So let's find the solution for this question. So we have 3x plus y is equal to 1. This is the first equation, and 2m minus 1x plus m minus 1y equal to m plus 1 second equation. Okay, so we write equation 1, equation 2 here, and we know here the coefficient of x is 3 in first equation and coefficient of x is 2m minus 1. This whole term inside the bracket is the coefficient of x in second equation, meaning this is a1, this is a2. Similarly here b1, coefficient of y is 1, nothing means 1, b1 is 1, and in second equation coefficient of y is m minus 1. So this whole bracket term is b2, b1 is 1, b2 is this, and this constant term c1, and this is c2. Okay, now let's see. So equation I wrote, now we will keep the condition is inconsistent, since the given equations are inconsistent. We'll give this condition, equations are inconsistent. So here we will not write the given equations will have inconsistent, because accordingly the term which we are using, accordingly the way of writing will change. The given equations are inconsistent, meaning no solution. So we can write here no solution, in bracket we can write. So this is the condition. Now we will use here a1 by a2, b1 by b2. First two are equal and the third one is not equal. So this is the condition for your no solution or inconsistent. Now let's substitute the values. a1 3 and this is a2, so 3 divided by 2m minus 1 is equal to, second, b1 is 1 and this is b2, m minus 1, so 1 divided by m minus 1, and third one not equal to c1 c2, c1 is 1 and c2 is 2m plus 1, 1 divided by 2m plus 1. So we substituted the value. Now we will solve to get the value of unknown m. Okay, so what we'll do here, so if you see here we get three relation. First relation is between these two, and the second relation is between these two, and third is between this and this. Okay, so we don't need to go for all those things, simply we'll pick up this first relation, first two relation, and from there we'll try to find out the value. Okay, so let's do, and after that we can go for this also. So here I'll take this 2, 3 divided by 2m minus 1 is equal to 1 by m minus 1, and this second, and 1 by m minus 1 is not equal to 1 by 2m plus 1. Okay, so let me repeat again. So in question number 1, if you remember, only one relation was there. I'll show you. Only one relation was there. See, this relation between these two only. So we got directly. But in this we have three relations, A1, A, B and C. So this is first relation, second relation, and again first and last, third relation. So we don't need to go for all these things. So we'll select, pick up directly first two relation, this two, 3 by 2m minus 1, 1 by m minus 1 I wrote here, and then I took second relation, 1 by m minus 1, and this. Okay, this I kept here. So we will solve both. So the first relation was 3 by, first relation was 3 by 2m minus 1 is equal to 1 divided by m minus 1. M minus 1. Okay, and let me write second also. 1 by m minus 1 was not equal to 1 by 2m plus 1. Okay, so these were the relation here. Now we can solve it. Next step, see, this two will do cross multiplication like this. 3m, see, 3 into m, you'll get 3m. 3 into minus 1 will get minus 3. This will multiply with 1, 2m into 1, 2m, minus 1 into 1 is minus 1. So we cross multiply this. And next step, keep this like term together, 3m and 2m. 3m, 2m will go towards left, so plus will change to minus 1, and 3 minus 3 will go to right side, you will get plus 3. So take care of this sign here. 3m minus 2m will give you 1m, so m equal to 3 minus 1 is 2. So I got m as 2. Okay, now let's solve this as well. 2m into 1, 2m plus 1 into 1, so plus 1. M into 1 is m, minus 1 into 1 is minus 1, but here it is not equal, so we'll write not equal. Again we'll write the like terms. 2m, this m will come towards left, this minus 1 will go there, plus 1 becomes minus 1. 2m minus m is m, and minus 1 gives you minus 2. But here I use equal to, we should use not equal to, okay, because this is the relation where they are not equal, so we'll use accordingly sign, that symbol we will use, not equal and here equal. So two values we got, one is m equal to 2 and m is not equal to minus 2. Alright, so here these two cases we got, so we can write here, hence the conclusion here, hence two values we are getting here. So except this minus 2, and here we got 2, no? So this thing we will write. So here we'll write, hence the given system of linear equations will have or will be will be, it was in that form, will be inconsistent for m equal to 2 and m not equal to minus 2. So this 2 thing will conclude in this way. Okay, so this is how we got the value of m. So then that means we can say except minus 2, say m is not equal to minus 2 and m is equal to 2, right? So we can say the value of m is 2 and not minus 2. All right, so this is how we conclude here. Okay, now let's move on to the next type question I kept here. This is the question here. See, for what value of p will the following pair of linear equations have infinitely many solutions? So it is clearly written here, infinitely many solutions. Px plus 3y equal to p minus 3, 12x plus py equal to p. So both the equations are here and condition is given. So we can easily find out this also. So let me write here solution. A question I'll write later on. Question 3. Solution here. Let's see this thing. So equation we have here, we have px plus 3y equal to p minus 3, equation 1, 12x plus py equal to p, equation 2. So we got both the equation. Now let's go for finding the value of p. Since the given equations have infinitely many solutions, therefore again we know for infinite many solutions the condition is all a1 b1 all the ratio are equal, a1 by a2, this is a2, b1 by b2 is equal to c1 by c2, all will be equal here. So let's substitute the values. A1 a2, it's p by 12, p by 12, b1 b2 3 by p, 3 by p, and c1 c2 p minus 3 by p. Now again we got relation here, 3 relation, this 2 and first and last. Again we'll go straight away, we'll take this first p by 12, 3 by p, I took this 2 here, and this 2, 3p, p minus 3 by p. Now let me tell you one thing, unlike in your previous question where we use this 2, here also I wrote both, first 2 here and second and third I wrote here. In case of that no solution, we need to write both. Okay, why? Because one was equal and other was not equal, but in this case all are equal. See, all are equal here, so we don't need to write this in two different times, or 2 times we don't need to write, any one will give you because all are equal. So that's why I will go for this only. So this I will reject here, this we will not take. So even if you solve this, you will get same thing. So that's why solving one is enough. If you, even if, as I said, even if you solve it, you'll get same thing, same answer. But in case of equal and not equal, we need to solve both. Okay, so p into p, cross multiply, p into p gives p square, 12 into 3, 36. Let's check here what we'll get. Okay, let me complete this. So p square, when I remove this, will give me root over 36. Okay, and this is nothing but plus or minus 6. We discussed this earlier. So we got ps plus minus 6. Now let's check here whether we get same value or not. See, p into 3, you will get 3p, p into p, p square, p into 3 minus 3p, right? Now what we can do, 3p, this negative 3p I can shift here towards left, so I'll get 3p, this minus become plus 3p equal to p square. Now 3p plus 3p will be 6p equal to p square. Now if you see, in both sides we have p common, here 1p, here 2 times p, p into p, so it is something like this, p into p. So 1p and 1p will get cancelled, and what we get, p equal to 6 equal to p. See, you'll get same value. So that's why we don't need to solve both. Okay, one side, if you solve any one of these two, you'll get the answer. So we can write here, so directly we can conclude here. So p equal to plus or minus 6. So we got, so these are the three application we discussed today, based on that condition for solvability of system of linear equation. So if you understand this, if you learn these three, you can deal any type of, or any such type of question which is available in your textbook or in any reference book. Okay, so I will wind up here with this three explanation of this application, and in next class we will see that algebraic methods. We will learn all those three methods which we need to use in solving pair of linear equation, which we call algebraic method, that we will do tomorrow. Okay, this much for today. Thank you.